Dawn drips rather than breaks in the mountains of Central Africa. Mist coils between giant heather trunks and the sodden stems of bamboo, swallowing sound and color alike. Every leaf carries a bead of cold that trembles under its own weight. In this pale half-light, a band of mountain gorillas begins to stir. The air smells of moss, iron-rich earth, and fermented fruit, the odor of a forest permanently caught between growth and decay. These slopes of the Virunga volcanoes hold one of Earth's densest concentrations of living biomass. Yet on mornings like this, it feels as if every gram of energy is wrapped in fog. Gorillas wake slowly, wake. Their nests, woven from pliant branches and layered with leaves, sag under the previous night's rain. Steam rises from their bodies as they shift and yawn. The dominant silverback, a hulking male whose hair clings to his shoulders in wet ropes, remains still until the youngest juveniles start to fidget. Only then does the troop's day begin. His chest, as broad as a car hood, serves as the troop's first source of heat. Infants crawl against it, pressing their bellies to the radiating warmth beneath the thick, water-shedding fur. The great ape's own body is a mobile furnace, fueled by fermenting vegetation, digesting in his capacious gut. When the rains intensify, gorilla families rarely climb higher into the mist zone. Instead, they descend 100 meters or so, into tangles of bamboo and giant nettle, where the stems grow tight enough to blunt the wind. These thickets are the gorilla's fog jackets, natural insulation belts that cut the chill. Their massive frames lose heat quickly when soaked. Hair alone is not waterproof, but the outer layer mats into a dense curtain that channels water away from the skin. Beneath it, a thin layer of fat and continuous microbial fermentation maintain an internal temperature surprisingly close to that of humans. In a world that often plunges near freezing, this biological furnace is life insurance. Huddling is strategy, not sentimentality. Females cluster with their infants between their thighs. Males sit outward, shoulders touching. The group becomes a breathing fortress against the cold. Inside that circle, humidity stays trapped, and carbon dioxide from exhalation slightly warms the microclimate. Biologists measuring those pockets found that the air temperature inside a gorilla huddle can climb several degrees above the ambient environment, enough to save precious calories otherwise burned by shivering. Evolution has tuned even their social structure for thermodynamics. Between squalls, the forest drips with delayed rain. Gorillas move in silence through waist-high bracken, each footfall cushioned by a mattress of decomposing vegetation. They feed in bursts, minutes of heavy chewing followed by motionless pauses. Rain-softened shoots yield more nutrients and are easier to tear. A silverback can strip a stalk of bamboo as thick as a wrist with one pull of his canines. Each plant they harvest also becomes an inadvertent engineer's act. Torn stems open the canopy just enough for light to leak through, encouraging the next generation of herbs and vines. In this way, even their appetites sculpt the forest's renewal cycle. The rain, though inconvenient to film crews and trackers, is a pulse of life. When storms pass, entire neighborhoods of plants surge into brief productivity. Gorillas know this rhythm with uncanny precision. After heavy downpours, they roam toward landslides and newly toppled trees, the fresh tables of the forest. Within a few days of exposure, dormant bamboo buds swell into tender green shoots rich in sugars, minerals, and silica. It is these ephemeral feasts that gorillas seem to anticipate, often arriving hours after a tree fall that no human observer could have heard. The explanation lies partly in sound transmission. Low-frequency rumbles travel far through wet air, and the gorilla's hearing is tuned to the sub-100 Hz register of cracking wood and shifting soil. Storms also rearrange scent. Water washes away the dominant chemical cues of old feeding grounds, replacing them with faint signatures from freshly broken plant tissue. Gorillas navigate this olfactory mosaic the way nomads read constellations. Their routes, repeated year after year, trace invisible rivers of smell and memory. A silverback can lead his group along a rain route that loops through valleys where bamboo grows fastest after storms, then upward again once berries ripen. Each circuit, lasting several weeks, balances calorie intake with minimal energy expenditure. An ecological choreography learned over generations and stored not in maps, but in collective intuition. Observe closely, and one sees that movement itself conserves heat. In drizzle, they travel in single file, shoulders brushing wet leaves, but avoiding open clearings where evaporative loss is greatest. Infants ride piggyback. Their tiny hands find purchase in the coarse hair ridge along the female's spine. Every stop is brief. When they do rest, they choose the lee side of thick trunks, faces turned away from the wind. Even these details, orientation, distance between individuals, posture, form part of a complex behavioral code shaped by meteorology as much as by predation risk. Despite their bulk, gorillas are masters of stillness. A resting troop appears sculpted from the forest itself, dark humps under dripping leaves, breath the only motion. But within that stillness lies physiological finesse. Their massive guts act as fermentation chambers where bacteria convert fibrous cellulose into volatile fatty acids, releasing heat in the process, an internal compost pile that never stops burning. The process not only sustains them on low-calorie plant diets, but doubles as a heating system. Energy losses from this digestion are minimal. Evolution has fine-tuned every aspect of their metabolism for slow, efficient living in cold, wet mountains. When midday fog lifts, the scene shifts. Sunlight filters through gaps, striking steam from their backs in silver plumes. Juveniles tumble and chest beat among vines, testing dominance boundaries under the watchful eye of the silverback. Play, while appearing wasteful, rehearses muscle coordination and balance for when adults must climb or fend off rivals. Even the timing of these bouts is thermoregulatory. Movement during short sunny intervals dries their fur, preventing fungal growth and reducing chill when the next squall returns. At higher altitudes where moss trees drip continuously, gorillas sometimes fashion temporary umbrellas from thick fern fronds, resting them across their shoulders as they feed. Though far from tool use in the human sense, this simple behavior demonstrates environmental awareness, a tactile adjustment to the elements. Observers have noted that individuals carrying infants more often use vegetation as cover, prioritizing the young's warmth. The gestures last minutes, yet in the evolutionary ledger, they speak volumes about cognitive flexibility. After prolonged storms, the forest transforms into a buffet. Treefalls scatter minerals long buried beneath the topsoil, and decomposing bark oozes sap rich in sodium. Gorillas descend to lick these spots, supplementing their otherwise low-salt vegetarian diet. Insects gathering around the sap become unintended snacks, adding rare protein. Each feeding site becomes a hub of biodiversity. Other species follow the gorilla's disturbance trails. Duikers sniff the residues. Hornbills probe the stripped stems, and even small primates forage in the aftermath. The gorilla is thus not just a consumer, but a catalyst, an architect of renewal in a biome defined by moisture and decay. As evening approaches, temperatures plummet. Mist condenses again, beading on every hair. The troop halts on a mid-slope bench dense with wild celery. Here they will sleep. Nest building resumes. Each individual folds branches downward into a springy mat, layering leaves for insulation. Infants are cradled inside adult nests rather than in separate ones, conserving energy during the coldest hours before dawn. The pattern mirrors an unspoken engineering principle: distributed warmth through shared mass. Even in slumber, social bonds serve physics. Rain drums through the night, louder than any call. Yet beneath that soundscape, the forest listens to itself. Frogs chorus from temporary puddles, and colobus monkeys bark distantly, their voices warped by fog. Gorillas, unlike many primates, rarely vocalize after dark. Silence keeps them safe from leopards, but it also preserves calm within the group. Their breathing merges with rainfall until the two become indistinguishable, the rhythm of lungs and water, life and weather. When morning returns, everything begins again. Steam rising, bodies shifting, a slow march through dripping corridors. But to the trained eye, each day's route differs slightly. Over the course of weeks, their trails weave a living topographic map, a rain route network linking mineral licks, chute beds, and thermal refuges. Ecologists tracing these paths find that they align with microclimatic gradients, places where fog lingers longer, where soil nutrients surge fastest after storms. The gorilla's world is not divided by north or south, but by temperature, moisture, and food pulse timing, parameters of survival encoded in instinct and experience. To understand them is to recognize that adaptation need not be extreme to be exquisite. No fur thickens into polar insulation, no migration spans oceans, yet within these damp ridges, evolution has sculpted a perfect equilibrium between physiology, behavior, and weather. The gorilla's fog jacket is more than hair. It is a system of community, metabolism, and landscape reading that turns perpetual rain from enemy to ally. Their rain routes are memory trails through an ever-changing green labyrinth, proof that intelligence in nature often manifests not through invention, but through harmony with constraint. In the end, the mountain's breath and the gorilla's breath are one. Mist rises, condenses, and falls again, feeding the same plants that feed the same apes that prune and spread their seeds. Rain creates life, and life in turn engineers rain's return through transpiration. The cycle closes as quietly as it begins, with a troop settling into its nests under a dripping sky, bodies steaming, hearts steady, and the forest ever patient, wrapping them once more in its grey, protective fog. Before dawn, the desert is a landscape of suspended breath. The stars are still hard and sharp, the sand cool enough to hold moisture, and the air briefly forgiving. In that narrow window between night and furnace, the baboons begin to move. Their silhouettes, wiry and angular, stretch across basalt outcrops and canyon rims like a living tide of grey fur. They travel with purpose, hugging shadow lines that still cling to the terrain. The first rays of sunlight do not illuminate them. They chase them. Every degree of warmth matters in this equation of survival. Across East Africa's semi-arid plains and cliff-laced gorges, troops of olive and chacma baboons have mastered a discipline few mammals can manage, the art of heat economy. Their survival here depends not on speed or strength, but on timing, posture, and the ancient logic of thermoregulation. In deserts and savannas where midday temperatures rise well above the tolerance of most primates, these animals have learned to treat shade as currency, rock as refrigerator, and breath itself as coolant. Their day begins before sunrise because their physiology demands it. A baboon's dense fur, perfect for highland nights, becomes a liability under the desert sun. Yet, beneath that coat lies a network of adaptations that allow this primate to outlast the heat where others would collapse. The chest and inner thigh are sparsely furred, leaving skin exposed as radiators. When the troop rests, those patches press against the cool stone of canyon floors or shaded boulders, heat dumps that siphon thermal energy from the blood. By dawn, those rocks have spent the night releasing stored chill from the previous sunset. A baboon lying belly down against one becomes an instrument of physics, drawing cold into its core through conductive transfer. Movement through the early light is deliberate. They follow invisible thermal maps traced in memory, shaded ravines, overhangs, and termite mounds that still hold cool air. The troop's alpha male leads from midline, not front. In this social geometry, the flanks buffer him from ambush, while juveniles test the edge of safety by scouting ahead. They are omnivores, but opportunists above all, plucking seeds, bulbs, and beetles while staying in the narrow belt of retreating shade. The desert, with its harsh gradients, forces an intelligence of scheduling. Every step, every pause, every feeding choice interlocks with a broader thermodynamic rhythm. As the sun rises, light floods the plain, bleaching color and flattening shadow. Within an hour, the ground itself radiates heat that can blister unprotected skin. For baboons, the response is choreography, not panic. They slow their pace, reducing metabolic output. Their tails droop to minimize surface exposure, their strides shorten to keep limbs closer to the body's heat core. Panting begins almost imperceptibly, a controlled release of internal warmth through the evaporation of moisture on the tongue. Unlike humans who sweat profusely, baboons conserve water by relying on precision respiratory cooling. Their mouths open slightly, drawing rapid, shallow breaths that expel heat without depleting fluids. Scientists call it mouth ventilating, but to watch it is to see calculation expressed through breath. Midday is the crucible. The troop halts entirely, clustering in the rarest of habitats, a cool island. These may be shaded cliff shelves, deep rock fissures, or even abandoned warthog dens whose interiors maintain a stable temperature many degrees lower than the air outside. Here, baboons wait through the inferno hours. The youngest cling to mothers' bellies. The dominant males sit erect, eyes half closed, conserving energy with monk-like restraint. In this stillness, each breath is a measured act of survival. The ground outside could fry an egg. The baboons' bodies simmer just below overheating, regulated by behavior, not anatomy. Their heat strategy is a masterpiece of evolutionary improvisation. Where physiological limits end, behavior compensates. Unlike desert reptiles that simply endure and bask, baboons forecast and adapt. They begin feeding again only when the sun angles low enough that shadows stretch and the land begins to exhale stored heat. The timing is instinctive yet flexible, guided by subtle sensory cues. The pitch of cicadas changes as air density shifts. Beetles crawl out from burrows when soil temperatures fall below critical thresholds, and the odor of cooling basalt carries faint traces of condensation. These signs tell the troop that the desert's oven is closing. Evening brings a reversal. The same rocks that were unbearable hours earlier now radiate comfort. The troop emerges, foraging with renewed energy. Grasses, now softened by heat stress, release sugars. Insects, shaken by earlier gusts, crawl sluggishly, easy prey. Some baboons dig shallow pits to uncover moisture-rich roots, each handful of earth revealing sustenance hidden from the burning air. The balance between effort and gain defines their feeding economy. Minimal energy spent for maximal water intake. It is not efficiency born of choice, but of necessity carved by climate. Thunderclouds, when they come, are not merely weather, they are revelation. A change in wind direction, the scent of ozone, or the low vibration of distant thunder can alter a baboon troop's entire route within minutes. They have learned that storms transform the land into sudden abundance. Termites erupt from soaked soil, beetle larvae rise from sand, and rain pools form micro-oases where insects drown and seeds germinate. The baboons become opportunistic foragers on the frontier of transformation, chasing storms across kilometers of terrain. What appears as chaos, a troop scattering toward the horizon, is actually precision, a race to exploit the ephemeral wealth of a rainstorm before it evaporates. When clouds burst, they do not flinch from the downpour. Their fur, though heavy when wet, shields against wind chill far better than against heat. They sit under overhangs or crouch against the lee of rocks, not to avoid the water but to manage it. As the storm cools the desert surface, baboons drink from shallow puddles with cupped palms and splayed fingers, absorbing minerals from dissolved dust. The rain's arrival resets the landscape's thermal balance, dropping ambient temperatures by several degrees in minutes, a natural reset switch for their physiology. Within that brief respite, they gorge, play, and reorient. Heat management in baboons is not simply about avoiding overheating, it is about maintaining function in an environment that punishes inefficiency. Their diet shifts with the seasons, not only to follow food, but to track hydration. Succulent plants like corms and tubers become primary targets during the driest months, while fruits dominate after rains. Every food item has a thermal cost. Chewing tough roots generates heat. Digesting fibrous stems demands water. By alternating feeding types, they balance metabolic heat load with ambient temperature. It is a metabolic accounting system as elegant as any engineered climate model. Predation risk, too, bends under thermoregulation. Leopards hunt mostly at dawn and dusk, the same hours baboons prefer to move. Yet their troop cohesion acts as thermal shield and defense network. The collective scanning of many eyes allows shorter, safer movements during cooler intervals. On scorching days when ambush cover is limited, predators retreat to shade, effectively granting baboons dominance of the open plain. The same heat that threatens their bodies suppresses their enemies. In this way, temperature shapes not just physiology but power dynamics within the ecosystem. When night finally returns, the transformation is palpable. The sand cools rapidly, and cold air pools in low ground. Baboons ascend cliffs to roost on narrow ledges, where nocturnal breezes sweep away residual heat. There, their bodies, still radiating warmth from the day, become small thermal lanterns against the dark stone. Sleep is communal, a fortress of fur and trust. The alpha male chooses a high vantage, both lookout and windbreak. Infants nestle deep between adults' limbs, absorbing their retained warmth. By midnight, the desert has switched polarity. What was once deadly heat becomes biting chill. The same physiology that risked overheating hours ago now conserves energy, aided by still air and shared contact. To watch this cycle for several days is to witness an organism in dialogue with the planet's mechanics. The baboon's survival is a conversation between biology and geology, between sunlight and shadow. Each behavioral adjustment, shade-seeking, panting, resting, feeding, threads into a continuous feedback loop where the environment dictates rhythm and the primate responds with intelligence shaped by generations. Desert heat management is not an isolated talent. It is a window into how evolution bends cognition to climate. Baboons possess sweat glands, yet choose restraint over use, knowing that water loss is fatal currency. They can climb trees but remain ground dwellers because soil radiates heat slower than branches do in open air. They organize movement around topography rather than random wandering, essentially turning geography into a living cooling system. In a world of scarcity, their minds act as thermostats. When dawn returns once more, the cycle begins anew. A faint wind ripples the dust, and the troop descends from its rock citadel. The first light hits the far escarpment, igniting it in gold. Already baboons trace their familiar shaded corridors, their breath visible in the chill. In another hour, the same ground will shimmer with unbearable heat, but for now, it is a landscape of precision and patience. Each step, each pause, each decision, part of an unbroken strategy honed by the necessity of balance. In the deserts and dry savannas of Africa, survival is not granted to those who fight the sun, but to those who negotiate with it. The baboon, stubbornly terrestrial among primates, has learned that lesson better than most. By reading temperature as language, by turning shade and stone into tools, it has become both student and master of heat. Its body, brain and behavior fuse into one seamless organism tuned to the pulse of climate itself. And when the horizon shimmers and the air warps with noon's invisible fire, the troop will already be gone, vanished into the maze of canyon shade and wind-carved refuges. They are not fleeing the sun, they are flowing with it, tracing the contours of survival along the fine line between heat and life. The wind comes first, low and metallic, whistling through the mangrove skeletons and bending the reeds until they creak. Clouds churn in slow layers of slate and bruised blue, and every creature that can read the air begins its quiet retreat. But the macaques do not run. Along the jagged coastlines of Japan, Taiwan, and Southeast Asia, troops of coastal and mountain macaques brace for the storm with a choreography born from centuries of repetition. For them, typhoons are not disasters. They are opportunities, windows of sudden abundance carved by the chaos of wind and tide. When the first rain arrives, the troop gathers high in the canopy, their fur soaked, but their instincts precise. They watch the sea from above the surf line, heads turning in synchrony as waves pound the shore. Hours later, when the storm's rage begins to ease and the ocean exhales its last convulsions, they descend. The beach is unrecognizable, driftwood jammed into sand, seaweed carpets glittering with trapped life, and puddles shimmering like mercury in the dull light. Here begins the macaques' coastal harvest. Their eyes scan for glinting shapes, stranded crabs, urchins, and mollusks tossed by the tide. Fingers, dexterous and chilled, probe through kelp tangles with the precision of surgeons. The intertidal zone, that treacherous frontier between land and sea, is now a buffet. The storm's violence has dislodged barnacles and flipped stones, revealing colonies of limpets and snails. In the brief calm after the tempest, macaques work the shoreline in coordinated bands, each individual tuned to the rhythm of the waves. Timing is everything. They forage between pulses, retreating in unison as the receding swells hiss back toward the deep. Rogue waves are killers, walls of water that erase the careless. Experience teaches the young through observation. The elders never turn their backs on the sea. A single mistimed reach can sweep a juvenile into the froth, yet risk has its reward. The intertidal harvest provides minerals rare in inland diets: sodium, iodine, and calcium, vital for bones, nerve function, and thermoregulation. These marine nutrients make coastal macaques among the most physiologically resilient of their kind, fortifying them for the next season's extremes. The ocean's bounty is not constant, and the macaques know it. As storm frequency increases during late monsoon cycles, they adapt their routes accordingly, following cliffs that funnel debris into narrow bays. Some individuals even cache cracked shells or stranded crabs among rocks, returning hours later once the tide has receded again. This form of delayed foraging hints at foresight, a planning behavior once thought exclusive to humans and apes. Evolution, it seems, teaches creativity through hunger. But the coastline is only half their stage. As seasons turn and the typhoon corridors fade northward, another drama unfolds inland, a transformation of color, temperature, and survival logic. In the highlands where Japanese macaques reign, winter presses down like a physical weight. Snow muffles sound, muting even the raucous calls that define macaque society. Trees sag under frost, and streams congeal into glass ribbons. In these conditions, most primates would perish. The macaques instead bathe. At the steaming pools of Jigokudani and other geothermal springs, entire troops descend daily, their faces flushed crimson against the pale steam. The first to enter are usually dominant females, followed by infants and subordinates in careful order. Immersion is not indulgence, it is biology. Water heated by volcanic vents can hover near 40 degrees Celsius, an oasis of warmth in sub-zero air. When a macaque lowers itself into the pool, the thermal gradient between its body and the water creates an immediate flush of heat exchange. Core temperature stabilizes, metabolic rate slows, and the animal conserves precious calories that would otherwise burn, maintaining body heat. Researchers measuring cortisol levels, hormones of stress, found that bathing reduces physiological strain during the harshest months. Yet not all individuals have equal access. Social rank dictates who soaks and who shivers. High-ranking females monopolize the best spots near the hottest vents, while juveniles and low-ranking males hover at the edges, dipping in cautiously or waiting for vacancies. Hierarchy in this frozen world becomes a thermostat. When they emerge, steam clings to their fur like ghostly halos. Grooming begins immediately, but not at random. They target critical areas first: the ears, fingers, and infant crowns. These extremities prone to frostbite must dry quickly to prevent conductive heat loss. Mothers cradle infants close, pressing them against bellies where dense fur and subcutaneous fat form living blankets. Each motion, each stroke of the hand through wet fur, is thermodynamics disguised as tenderness. The bath ritual has social consequences beyond warmth. Grooming within the hot spring troop strengthens alliances and reaffirms rank. Bonds formed in steam often translate to cooperative defense or shared access to food later in the season. The spring thus becomes more than refuge. It is a social forge where temperature and politics intertwine. Outside the pools, winter's austerity dictates an entirely new feeding logic. The lush diets of summer, fruits, flowers, and insects, vanish under snow. What remains is bark, buds, and the ghosts of autumn abundance. Macaques, however, remember. In early fall, they cache seeds and nuts, burying them beneath leaf litter or in tree crevices. These caches, spread across territories, become a memory map, a mental database stored through hippocampal navigation. When snow covers the forest floor, they excavate those remembered sites with uncanny accuracy, revealing not random digging but spatial recall comparable to food-storing birds. When even stored resources dwindle, they turn to cambium, the living tissue beneath bark. With teeth honed from constant foraging, they strip narrow bands from tree trunks, feeding on the sugary sap that flows between bark and wood. It is a costly act. Remove too much and the tree dies, eliminating a future resource. Remove too little and hunger lingers. Their foraging patterns therefore demonstrate restraint, an intuitive understanding of sustainable yield. The forest gives, but only to those who listen to its limits. In these snowbound weeks, macaques radiate an adaptability that borders on artistry. They navigate blizzards with the same cognitive map that once guided them through coral-strewn beaches. Temperature is merely a parameter to be negotiated, not an obstacle to existence. Even their fur changes seasonally. Denser undercoat growth begins as daylight shortens, adding insulation, while outer guard hairs thicken with natural oils that repel water and snow. Predators shape their vigilance. Golden eagles and mountain foxes hunt the weak and the unwary, but the collective strength of a troop provides insurance. They position sentinels along ridges, while others feed below, rotating duties to maintain alertness without exhausting any individual. Such cooperation is not altruism in the human sense, it is survival calculus. Each watchful eye increases the odds that genes shared across kin will persist. By late winter, when snowmelt begins to carve channels through the ice, the macaque's endurance is rewarded. Early thaw reveals shoots of grass and dormant insects. Troops shift downslope, trading the hiss of hot springs for the gurgle of returning streams. Infants born during the depths of winter now cling to mothers whose coats shed in slow drifts of fur, signaling the season's turn. The landscape awakens, and with it, the familiar cycles of hierarchy and play. The storm coast and the frozen forest might seem like separate worlds, yet they are bound by the same principle: timing. Whether reading the retreat of a wave or the advance of frost, macaques live by precision in motion. Typhoon or blizzard both represent systems of disturbance, and the macaques have evolved not to resist, but to align. Their survival depends on sensing when chaos becomes opportunity, when water, wind, and heat can be manipulated rather than endured. It is easy to anthropomorphize these scenes. The stoic face of a macaque in a snowstorm, eyes half closed in the steam, looks almost meditative. But behind that serenity lies rigorous adaptation. Their bodies act as environmental instruments, regulating temperature through behavioral sequences that rival any engineered design. Their intelligence is not abstract reasoning, it is sensory fluency, a dialogue between physiology and weather that allows them to live at the intersection of extremes. As the last snow fades and spring insects emerge, the troop resumes its omnivorous wanderings. The young chase one another through thawing glades. Adults sit along riverbanks, peeling bark and watching for ripples that might hint at fish or crustaceans. Storms will come again, new typhoons, new floods, and when they do, the macaques will be waiting. They will read the shifting sky with the same calm authority that has carried them through millennia of change. Theirs is not the resilience of brute endurance, but of adaptation through intelligence, a mastery of rhythm in a world of volatility. In the typhoon and the hot spring alike, the macaques prove that survival favors not the strongest nor the fastest, but those who can listen to the planet's pulse and move precisely in time with it. Morning arrives not with silence, but with resonance, a rolling, chest-deep roar that vibrates through the forest before the light even reaches the leaves. The sound comes from throats lined with an echoing chamber of bone, a resonating hyoid the size of a clenched fist. This is the voice of the Howler monkey, the jungle's barometer, announcing its position, its dominance, and in subtler ways, the coming weather. To the untrained ear, it is a cry of defiance. To a biologist, it is a calculation, a sonic measure of air density, humidity, and shifting wind that tells the troop when to rise and where to move next. Above the canopy, the wind gathers itself. It funnels between emergent trees and shakes the crowns like the sea tossing its waves. For most creatures of the rainforest, the wind is an inconvenience. For the howlers, it is geometry, a daily problem to solve. They are built for the canopy's vertical architecture, not for stability under pressure. Every gust transforms branches into levers and pendulums, and a single misjudged movement can turn a meal into a fall. So as the wind strengthens, the troop begins its descent. From the ground, the shift is nearly invisible. Only a trained observer would notice how the dark shapes move downward, branch by branch, from the exposed emergent crowns into the quieter mid-canopy. This descent is not panic, it is energy arithmetic. At the top, branches whip violently, forcing the monkeys to clutch and sway with every gust, each movement burning calories they cannot afford to waste. Below, in the denser middle layers, the air is calmer, filtered by foliage. By dropping 20 or 30 meters, they reduce kinetic stress, conserve grip strength, and shield themselves from the mechanical fatigue that can accompany hours of balance under motion. Energy for a howler is everything. Their diet, almost entirely leaves, is rich in fiber, but poor in calories. Digestion takes time, and the fermentation process within their enlarged gut produces methane and heat, but little immediate energy. Every calorie saved through behavioral efficiency is a step closer to survival. Their lives are ruled by slow math, the economics of motion versus digestion. To live high in the trees on a low-energy diet requires an evolutionary accountant's precision. Even their signature vocalizations serve a metabolic purpose. Roaring to warn rival troops away saves them the cost of defending territory through physical confrontation. Sound replaces violence, vibration replaces chase. When the wind rises beyond comfort, the monkey's feeding strategy changes with it. They select leeward trees, those on the downwind side of the forest, where leaves tremble less and are easier to grasp. In these sheltered pockets, the canopy acts as a natural windbreak, allowing the troop to move quietly and feed efficiently. The choice is deliberate. Fewer leaves lost to turbulence means less time spent searching for replacements. This behavior is subtle, but across a lifetime it shapes survival odds. Scientists studying foraging routes have found that howlers adjust their daily paths according to seasonal wind direction, showing a sophisticated awareness of aerodynamics and energy expenditure that rivals the precision of migratory birds. Wind also dictates sound. Their booming calls travel differently depending on air temperature and humidity. On calm, moist mornings, the roar can reach several kilometers, flattening into a low, rolling echo that marks territory far beyond visual range. But when the wind rises, it scatters the sound, forcing males to shift their positions, descending into gullies or mid-level corridors where acoustic distortion is reduced. In this way, their movements form an invisible network of sound corridors through the forest, designed not for sight, but for communication efficiency. As storms build, behavior tightens. The troop clusters along thick boughs, pressing close to the trunk where wind shear is weakest. Their tails, prehensile, muscular, and calloused at the tip, wrap around branches with quiet precision. These tails are more than balance tools. They are fifth limbs equipped with skin as sensitive as human fingertips. Each tail's grip pressure changes instinctively with wind speed, adjusting their stability in real time. During stronger gusts, infants are pressed belly to belly against mothers, wrapped not only in arms, but also in the coiled safety of tails. This trinity of grip, hands, feet, and tail, allows them to ride out tempests that would strip birds from the air. After rain, the forest changes texture. Leaves glisten, heavy with droplets that magnify the light. The howlers, damp and shivering, climb out of their mid-canopy refuges and seek what researchers call solar parks, open, east-facing boughs that catch the first rays of morning sun. They arrange themselves like sundials, each body turned toward warmth, fur steaming gently as it dries. This ritual, observed across multiple populations, serves not only to raise body temperature, but also to recalibrate internal rhythms after long, cold rains. Their digestion depends on heat. Fermentation within the gut slows dramatically when body temperature drops, delaying energy absorption. Sunbathing, then, is not luxury but necessity, a physiological restart after thermal stress. From above, the sight is oddly symmetrical, a dozen dark shapes basking in silence, the forest steaming below them. These primates, often caricatured for their vocal noise, are among the rainforest's most contemplative creatures when the weather breaks. Their patience is evolution's masterpiece. Every decision, from when to feed to how long to bask, follows an internal calculus tied to both weather and metabolism. They are creatures of rhythm, tuned to the invisible pulses of light, heat, and air pressure. Wind, however, is not merely something they endure. It has become an ally in their ecological role. As they feed on new leaves, they stimulate regrowth by pruning the forest canopy, allowing filtered light to reach understory plants. By dropping uneaten leaves, they enrich the soil below. During windy seasons, the combination of falling leaves and monkey movement accelerates nutrient cycling, indirectly feeding the very trees they depend on. Their existence, measured in small acts of eating and resting, becomes a form of ecological engineering. Predators, too, read the wind. Jaguars and eagles hunt by scent and sight, but wind confuses both senses. The howler's choice to move leeward also disrupts predator detection. Wind carries their scent away, making ambush more difficult. In this way, a simple foraging preference doubles as defense. Their seemingly slow, cautious manner hides a deep awareness of threat geometry. Stay where wind muffles movement, where scent disperses away from the forest floor, and where sightlines blur in swaying foliage. What appears to be laziness is, in truth, environmental mastery. When cold fronts sweep in from the north, especially in highland forests, the troop becomes a study in thermal management. Their thick fur traps air close to the skin, creating an insulating layer that rivals that of Arctic foxes relative to body size. Yet moisture can nullify that protection, so they avoid low fog zones and seek ridgelines where the wind dries their coats faster. By mid-morning, as the sun climbs and the canopy begins to hum with insect life again, they resume their slow-motion commute through the trees. Each movement, each pause is deliberate, a pendulum rhythm of conservation and necessity. In the drier months, when winds are constant but rains fade, howlers alter their diet to include more mature leaves, which contain higher fiber and lower moisture. This shift raises their water demand, but rather than descend to drink, they exploit the forest's microclimate. Water droplets trapped in leaf axils, morning dew collected on vine cups, and the occasional rain pooled in bromeliads provide hydration without risk of ground-level predation. Their tongues are remarkably agile, capable of curling to sip from cavities only a few centimeters wide. Even their feeding order changes. They eat younger leaves in the morning when moisture is highest, older leaves later when dehydration risk lessens. Every choice is optimization, a survival algorithm written in behavior rather than thought. As afternoon storms return, the howler's movements mirror the pattern of morning. They shift again toward the interior canopy, anchoring themselves in predictable rest sites that provide structural stability against wind. Researchers tracking troops over years have found that they reuse the same trees during high wind seasons, anchor points that serve as both refuge and memory landmarks. These trees, often massive cebas or fig giants, stand at the intersection of canopy corridors and serve as communal hubs, not unlike human villages in miniature. Beneath them, the forest floor is littered with seed-rich feces, evidence of their role as key seed dispersers for more than 70 plant species. By nightfall, the forest wind softens, crickets resume their chorus, and humidity climbs. The howlers settle into clusters along heavy branches, tails wrapped like harnesses. The last light flickers across their black fur, revealing the slow rise and fall of steady breathing. They do not build nests like chimpanzees or orangutans. Their rest is balance learned from birth. To sleep in a tree that moves is to trust physics, to understand that stillness can exist within motion if one aligns with it. Wind has shaped the evolution of these monkeys as surely as diet or predation. It governs when they climb, where they feed, and how they call. It dictates muscle tone, energy budget, and even social spacing within the canopy. Through it all, the howler remains an emblem of patience in motion, a creature that listens to air, measures its pulse, and adjusts accordingly. By dawn, their roars will begin again, echoing through valleys like the earth's own thunder. But those roars are not random defiance. They are data. Each bellow carries the density of air, the moisture of clouds, the promise of rain or calm. Through sound and wind, the forest itself communicates, and the howlers, with their vast lungs and disciplined energy, are both interpreters and messengers. In their rhythm, one finds the truest logic of the canopy. Survival is not a battle against weather, but a conversation with it. Before the first thunder rolls, the forest begins to tremble. The canopy, a web of leaves and light that once shimmered in still air, now ripples like a living sea. Branches flex under invisible weight, bending and swaying in long resonant arcs. Far above the forest floor, where wind is a tangible thing, the gibbons already know what is coming. Their world exists at the intersection of motion and air, and when the monsoon builds its breath, they read its intentions the way sailors read tides. Gibbons are born to the canopy's void. Every limb, tendon, and muscle fiber in their bodies has evolved for a life in suspension. Their shoulders, uniquely ball and socketed, rotate almost a full circle, allowing a range of motion unknown to any other primate. Their elongated arms, nearly twice the length of their torsos, convert gravity into rhythm, each swing a calculated parabola through air. To move efficiently through this vertical labyrinth requires a physics of instinct. They do not merely jump. They calculate trajectories in real time, adjusting for branch thickness, distance, and the elasticity of living wood. In the dry season, their flight paths are predictable, a symphony of long arcs between stable perches. But when the monsoon arrives, the forest rewrites the laws of motion. The first gusts turn their highway into a shifting puzzle. Moisture softens branches, changing stiffness and rebound. A limb that once supported an adult's weight now bows several centimeters lower, altering the geometry of every leap. The gibbons respond not with hesitation, but with recalibration. Their circuits, habitual routes linking feeding trees, roosts, and territorial boundaries, are rerouted in hours. They shorten the gaps between swings, lower their launch angles, and add an extra point of contact mid-flight. What looks to the human eye like improvisation is, in truth, a precise adaptation to fluid mechanics. Each grip, each release is informed by the forest's elasticity under rain. Wind alters not just movement, but communication. Gibbons are famously vocal. Their duets, sung by mated pairs at dawn, rise above the forest like music from a cathedral. These calls serve as territorial declarations, pair bond affirmations, and atmospheric tests. The structure of their song, long resonant whoops rising to high, trembling peaks, is tuned to carry across kilometers of dense foliage. Yet when monsoon winds churn and storm noise swallows frequencies, the songs change. Duets become shorter, closer, and lower pitched, designed for nearby exchange rather than long-distance broadcast. The pair's coordination, a complex interplay of timing and pitch, tightens under pressure. To human listeners, it sounds subdued, a muted chorus, but within that restraint lies adaptation. Their voices, shaped by evolution's feedback loop, act as barometers of the weather itself. In the thick of the monsoon, the canopy becomes a dangerous place. Gusts shear through the upper layers, hurling twigs and fruit with lethal force. The gibbons retreat downward, threading through the mid-level lattice where the wind's reach weakens. Here in the calmer air, leaves drip constantly, forming silver curtains of runoff. The smell is sharp, wet bark, sap, and ozone. Movement becomes conservative, less brachiation, more climbing, slower transitions between trees. They huddle in family units, arms wrapped around one another, dense fur shedding rain as efficiently as a woven cloak. When storms peak, they anchor themselves. Using both hands and feet, and often their powerful tails, in species that possess rudimentary ones, they press low along branches to distribute force. Their small, compact torsos allow them to flatten their bodies against wood, minimizing drag. Raindrops strike with the ferocity of thrown pebbles, but the gibbon's fur, a fine, insulating double layer, channels water outward while retaining warmth beneath. They are not waterproof, yet they are never soaked. Their coat works like thatch, shedding droplets before they reach the skin. Thermoregulation in these moments is not passive. They contract muscles beneath the fur to trap air, creating a microclimate that holds body temperature even in wind-chilled rain. Then, as quickly as it arrived, the storm exhausts itself. The wind softens, the forest exhales steam, and the gibbons emerge transformed. They test the air, tasting humidity and pressure through subtle shifts in nostril flare and skin sensation. Their movements, tentative at first, become exuberant, an aerial ballet of recovery. Post-storm forests are alive with opportunity. The deluge has shaken loose flowers, cracked pods, and scattered insects across the canopy. Water glints on every surface, and the sound of dripping leaves provides a metronome for the troops' revival. At river edges, where rain runoff meets forest flow, insect hatches explode. Clouds of mayflies and caddisflies rise from the water in synchronized emergence, their fragile wings glinting like flakes of glass. The gibbons descend toward these edges, launching tight, circular loops through the still dripping branches. They time their movements to the brief window when the air is thick with prey, a protein pulse rare in their fruit-heavy diet. In mid-leap, one might snatch a large dragonfly or a stray cicada, the crunch audible even over the river's murmur. What looks like play is a calculated feast, foraging efficiency dictated by the rhythm of water and light. Their energy balance in this season is delicate. Fruits ripen irregularly, washed away or spoiled by excess moisture. To compensate, they expand their foraging range, sometimes doubling the distance between feeding trees. This expansion demands navigation in a landscape made treacherous by slick bark and weakened limbs. Yet even here, evolution has prepared them. Gibbons possess an extraordinary sense of proprioception, an internal map of limb position in space that allows them to predict movement without sight. They can swing through foliage they cannot see, relying on muscle memory and the subtle vibration of branches to infer distance. In storms, when visibility drops to near zero, this sixth sense becomes their lifeline. When light returns, the gibbons resume their songs. Steam rises from the canopy and tendrils, and shafts of gold pierce through the residual haze. A pair, perched on a sun-warmed trunk, begins its duet anew. The male's booming notes travel across the valley, each phrase cascading like a wave. The female's higher replies thread through his call, weaving counterpoint and harmony. Together their voices mark both territory and reunion. The storm has passed, and the forest is theirs again. The duet's duration and intensity often match the weather's calm. The longer the silence of wind, the more expansive the song. In this way, the gibbon's music becomes a meteorological chronicle, encoding atmospheric history in sound. Behaviorally, the monsoon shapes their social dynamics as much as their movement. During prolonged rains, when food scarcity heightens tension, grooming becomes currency. Family members exchange warmth and trust through meticulous fur cleaning, removing debris, parasites, and trapped moisture. These sessions, lasting hours, are more than hygiene. They are psychological stabilizers. Physical contact lowers stress hormones, synchronizes breathing, and reaffirms bonds in an environment where isolation means vulnerability. Monsoon adaptation in gibbons extends even to reproduction. Birth peaks often occur just before the rains, ensuring that lactating mothers have access to the insect surge and young leaves that follow storms. Infants carried ventrally in the early months benefit from their mother's insulating body heat and the waterproofing provided by dense belly fur. As they grow, they learn the aerial trade by imitation, first with short, tentative reaches under parental supervision, then longer, riskier swings during calm spells between storms. Ecologically, gibbons serve as pollinators and seed dispersers for dozens of tree species. After monsoon rains, many trees depend on them to transport seeds to drier ridges, where germination succeeds. Their tendency to feed along wind-protected corridors ensures that seeds are deposited in microhabitats shielded from erosion and flooding. In this way, their storm season behavior directly contributes to the forest's recovery cycle. The gibbon's monsoon is not merely endured, it is harnessed, transformed into a mechanism of renewal. From the ground, one can watch their silhouettes cut through vapor trails of mist, arms outstretched, bodies almost weightless. Each leap arcs through filtered light, droplets scattering like sparks. The precision of their motion under such conditions defies human intuition. They appear to hang between branches for impossible moments, suspended in the equilibrium between gravity and will. Every swing is a conversation with physics, every branch an answer. To live where air itself is unstable, where branches twist and sound dissolves in rain, requires an intimacy with the elements that humans have long forgotten. Gibbons read the monsoon not as threat, but as rhythm. Their movements are both reaction and prediction, a choreography dictated by the pulse of wind through leaves. When the storm breaks and silence returns, their songs rise again, carrying the story of endurance and adaptation across the drenched canopy. And in that echo, somewhere between thunder's retreat and sunlight's return, the forest listens back. The gibbon's voice, shaped by air and weather, becomes the pulse of the monsoon itself, resilient, mathematical, and alive. Dawn over Borneo's river labyrinth does not come quietly. The mangrove channels stir long before the light reaches them, their roots flexing in the tide like fingers waking from sleep. The air is thick with humidity, heavy with the sweet rot of vegetation, and layered with sound, the rasp of insects, the squawk of hornbills, and somewhere deep in the estuary's folds, the soft nasal honk of the proboscis monkey greeting the day. To live here in this world ruled by tides and floods demands not just agility but foresight. Every tree, every current, every shift in wind carries information, and the proboscis monkey, with its comically oversized nose and swollen belly, reads that information with a precision born of necessity. The river is both home and hazard. By day, its calm surface mirrors the sky. By night, it hides eyes that glint just above the waterline. Crocodiles patrol these channels like living shadows, their patience outlasting the sun. For the proboscis monkeys, survival means understanding water's moods. They know when the tide will climb high enough to swallow the mangrove roots and when it will fall back to reveal slick mudflats filled with crabs and snails. This knowledge shapes every aspect of their lives, where they sleep, how they travel, what they eat, and even how they breathe in the still heat of flooded air. Families, small troops of females, infants, and a dominant male, spend their nights perched above high tide marks, often on riverbank trees whose lowest branches remain just beyond the reach of rising water. These trees serve as both bed and fortress. The choice of elevation is precise. Too low, and a surprise king tide could submerge their refuge. Too high, and the exposed branches leave them vulnerable to eagles and wind. The male, distinguishable by his massive pendulous nose and copper fur, inspects the chosen perch before dusk. His inspection is tactile. He grips each branch, gauges its thickness, and listens for the faint tremor of flexibility. A sleeping branch must hold not only his weight, but the cumulative motion of wind, rain, and tide. When the king tides roll in, those rare astronomical swells when the ocean's pull climbs to its zenith, the rules of the forest change. Channels flood far beyond their usual reach, swallowing even the tall nipa palms. The monkeys abandon their habitual riverside haunts and move to higher levee ridges, natural embankments formed by centuries of sediment buildup. Here, on these narrow spines, they navigate a precarious corridor above the floodplain. The mangrove canopy arches overhead, its roots creating submerged tunnels where currents slow and eddies form. These archways, half forest and half water, become the refuge of the flood season. Crossings are the most perilous moments of all. When a troop must move between flooded trees or from one river bend to another, every jump is an act of calculated risk. The male leads always. He tests branches with both hands before committing, shifting his weight in small increments. If the bark gives too easily, he chooses another route. Once he decides, he signals, not with sound, but with motion. His tail flicks, his body leans forward, and the rest follow in near-perfect synchronization. By crossing together, they minimize the window of vulnerability. Crocodiles, triggered by ripples and splashes, struggle to target multiple moving points at once. A synchronized leap buys safety through confusion. Not all crossings are successful. Scars tell stories of close calls, a missing finger here, a torn foot there. Yet the method works well enough that entire generations have survived in these tidal corridors, their instincts refined by the river's rhythms. Observers have noted that juveniles begin mimicking the testing behavior of adults months before they attempt their first real leap. The learning process is kinesthetic, a physical education written in muscle memory, not imitation. They learn not where to jump, but how to read the wood. After the storm surges and heavy rains, the mangrove world resets. Saltwater retreats, leaving behind layers of silt rich in minerals and decomposing organic matter. The trees respond almost instantly. Within days, new shoots burst from branches, young leaves, pale and supple, untainted by the bitter tannins that dominate older foliage. The proboscis monkeys know this timing intimately. Their leaf-based diet depends on fermentation within a complex multi-chambered foregut, an adaptation parallel to that of ruminants. These new leaves, low in chemical defenses, are perfect fuel for their microbial factories. Feeding begins at dawn and continues in slow, methodical sessions. They pluck leaves delicately, choosing the youngest and thinnest first. Every bite passes through a gauntlet of fermentation chambers where symbiotic bacteria break down cellulose into digestible compounds. The process generates methane, so much that the monkeys' rounded bellies act as living fermentation tanks, distended with gas and partially warmed by internal chemical heat. It is not aesthetic, but it is efficient. Their system extracts nutrition from what most primates would find inedible. Yet even this efficiency has limits. Tannin-rich leaves, the defensive arsenal of older foliage, can suppress their gut microbes. Hence the race after rains, to harvest the fleeting window of tenderness before chemistry hardens again. Post-flood feeding patterns reveal another layer of intelligence. The monkeys travel upstream after heavy rains, following the gradient of freshwater dilution. Here, salinity is lower and trees flush earlier. This upstream migration is subtle, almost invisible from above, a daily adjustment of territory that tracks both water chemistry and plant physiology. In ecological terms, they are bioindicators, responding to changes in salinity and sediment faster than most instruments could record. Their movements, recorded over months, trace the pulse of the river itself. During low tide, the forest exposes its underworld. Roots twist upward like petrified serpents, and the smell of anaerobic mud thickens in the air. The monkeys descend cautiously, not to the ground, but to the lowest reachable branches, scanning for edible shoots and the occasional crustacean trapped in tide pools. They are not strict herbivores. Opportunistic omnivory gives them vital protein during lean seasons. A well-timed grab at a crab or prawn supplements the meager calories of leaves, balancing their nitrogen intake. This dietary flexibility is one of their most overlooked survival traits, an adaptive bridge between forest and sea. Predation is never far from their minds. Crocodiles are not the only threat. Clouded leopards prowl the canopy, and pythons coil in the shadows of fallen trunks. Yet the greatest risk remains the water itself. Floods alter the acoustic landscape. Sound behaves differently in dense, humid air. The rustle of a predator's movement is dampened, echoes distort distance. The monkeys compensate by relying more on vibration and visual signals. A sudden stillness in the troop is often the first sign of alarm. Ears pivot, eyes track below, and within seconds they ascend higher into the branches where footing is sure and vision clear. As the rains subside and the dry months return, the estuary transforms again. Water levels drop, and sunlight filters through gaps in the canopy. Algae bloom along exposed roots, and the smell of brine thickens as evaporation concentrates the salt. The monkeys adjust their roosting height downward, returning to familiar sleeping trees near the waterline. The cycle is endless: rise with the flood, retreat to the levee, return with the ebb. Each phase is accompanied by a reshuffling of territory and hierarchy. Males bellow deep, resonant calls across the river, their nasal chambers amplifying sound like organic trumpets. These calls, carrying over the water, declare ownership and readiness. Social life unfolds within this watery choreography. Males maintain small harems, their dominance enforced not through constant aggression, but through position. The one who controls the safest sleeping site controls reproduction. Females, far from passive, Evaluate males by stability. Those who consistently secure high tide refuges and lead successful crossings win loyalty. In this way, even sexual selection intertwines with hydrology. Water, not force, shapes the genes that persist. By evening, the light fades to copper and the tide turns once more. The river, now glassy and still, reflects silhouettes of long limbs and pendulous noses. Families settle into sleeping clusters, juveniles grooming parents as cicadas crescendo in the background. Below, crocodiles drift silently, eyes fixed on the branches above. The balance is delicate, but ancient. The monkey's weight distribution, the branch's arc, the water's height, all parts of a mathematical conversation that has continued for millennia. In this tidal world, adaptation is not invention but rhythm. The proboscis monkey's life is a sequence of adjustments measured in centimeters of water, degrees of salt, and minutes of sunlight. Their survival depends on reading these metrics as clearly as others read words. Theirs is an existence sculpted by flood and ebb, a life in constant negotiation with the river's will. And when the next tide rises, slow, relentless, and shining with the moon's pull, they will rise with it, exactly as they always have, suspended between forest and sea, in perfect synchrony with the planet's most ancient pulse.